Hey everyone, I'm Brandon Graisley. I'm a high school math teacher. We're going to talk about these special triangles. These are two right triangles that help us calculate the trig ratios for certain angles, the ones that come up a lot, and they just work out to really nice numbers. So this is really just a memory aid. Let's start with the first one here. This is an isosceles triangle. The two short side lengths are each 1, and you could use the Pythagorean theorem to calculate the other side length, which is the square root of 2. So it's a 1, 1, root 2 triangle. Because it's isosceles and it's a right triangle, we know that these must be 45 degrees. So the reason we have this is if you want to calculate the sine, cosine, or tangent of 45 degrees, you can use this triangle as a quick memory aid for doing that. So let's do that right now, and then we'll go on to the other triangle. So the sine of 45 degrees, using, let's say, this one as a reference angle, opposite divided by the hypotenuse, is 1 divided by the square root of 2. How about the cosine? The adjacent side is also 1 divided by root 2, so that's the same number. And last we have the tangent. Opposite side length divided by the adjacent side length is 1 divided by 1, and I'll just write the number 1 for that. Now, just before we move on, these ones here have an irrational number, square root of 2, as a denominator, and it's conventional for us to rewrite this by multiplying top and bottom by root 2. You'll end up with this equivalent value here, root 2 divided by 2. So for example, a lot of calculators will give you this number, or this form of the number, as an answer if you typed in cosine of 45. Let's check it out on my Casio FX300 ES Plus. Cosine 45 degrees, sure enough, root 2 divided by 2. Okay, let's talk about the other triangle. Now this one also has a side length of 1 as the shortest side. The hypotenuse is 2, not root 2, fully 2. And once again, if you use the Pythagorean theorem, you get the square root of 3. Now it turns out that this triangle is a 60 and a 30 degree in these two corners here. So we have a 30, 60, 90 triangle, another really common one with some pretty nice numbers. Let's check these ones out. The sine of 30 degrees, so using 30 as our reference angle, the opposite side length is 1, and the hypotenuse is 2, 1/2. The cosine of 30 degrees, adjacent side is root 3, dividing by 2, and last we have the tangent of 30 degrees. Opposite is 1, adjacent is root 3, so that's 1 over root 3, or it's very commonly written as root 3 over 3. Okay, we've got just enough room to finish off the 60 degree ratios over here. Sine of 60, opposite is root 3, hypotenuse is 2. Cosine, adjacent to 60 is 1, and hypotenuse is 2. Now you'll see the cosine of 60 and the sine of 30 match, cosine of 30 and sine of 60 match. And last we have the tangent of 60 degrees, using 60 as our reference angle. Opposite divided by adjacent is root 3 divided by 1, or we can just write root 3. So now we have a nice numerical representation for each one of these different ratios. We can use this to evaluate expressions with exact values. For example, let's do a few of these. What if we needed to know what is the sine of 45 degrees times the cosine of 60 degrees? Well, the sine of 45, if I look up here, I can look at what I've already written, or I can go right to the triangle. Sine of 45, opposite over hypotenuse. Let's write it like that, 1 over root 2. Multiplying that by the cosine of 60 degrees, that was 1/2. So I can get an answer of 1 divided by, multiplying the bottoms here, I get 2 root 2. If you rationalize that denominator, so if you already have this skill, we're going to multiply top and bottom by root 2. That's the same as multiplying by 1, but we won't have any irrational numbers left in the denominator. We end up with root 2 on the top, and on the bottom it's 2 times root 2 times root 2. That comes out to 4, and that's our most conventional way to write that one. Let's do one more. How about the tangent of 30 degrees minus the sine of 45 degrees? So we're subtracting this time. We have root 3 over 2 for the tangent of 30. Sorry, I wrote that wrong. Root 3 over 3 for the tangent of 30. That's better. And then for the sine of 45, root 2 over 2. Now, because we're subtracting these two fractions, we need a common denominator. That will be 6 in this case. So multiplying top and bottom by 2, that'll be 2 root 3 over 6 minus 3 root 2 over 6. I'm going to subtract those numerators. 2 root 3 minus 3 root 2. And because those are different radicals, like root 3 and root 2 are different from each other, we can't simplify that any further. Now, if you want to double check this with a calculator, if you have a fancy calculator like a Casio FX300 ES Plus, you can type these in directly. A lot of calculators, though, will not give you these nice exact answers. So in my case, I do get that nice exact answer. Okay, that's all. If you have any questions, comment below, or if you're in one of my classes, you already know how to ask me questions. Talk to you soon.